What I will discuss now is the measurement. You may wonder, sir, the measurement already we discussed. So if I measure it, it comes into the the state of as it was written here, a 0 or a 1 state depends upon your probabilistic amplitudes. There is something beyond that. Off yeah. So now how I am going to measure it? Okay, I can measure in multiple bases. Okay, what so far we discussed is measuring in the computational basis. Okay, what is meant by measuring in computational basis? Whatever we discussed so far, whether it falls under 0 state or 1 state, is measuring in the computational basis. That means Z basis. I can measure it in X basis. I can measure it in Y basis also. Any given qubit. How do I measure it? So a set of distinct measurements outcomes is called basis, right? So you have Z basis with 0, 1. You can have a positive superposition, means plus, where in which you have 1 by root 2 ket 0 ket 1, and then minus, which is the other side of the X basis, 1 by root 2 ket 0 minus 1, which is X basis, and I have Y basis, wherein which I have 1 by root 2 ket 0 plus I ket 1 minus I, which is the other side of the Y basis, 1 by root 2 ket 0 minus I1. What is this plus I and minus I? Is the phase. Okay, this is called phase. A phase shift. Okay, so I have multiple bases like this. I have Z basis, wherein which I have 0, 1. I have X basis, I have plus, minus. So you have Z basis, wherein which you have ket 0, ket 1. You have X basis, you have the measuring states plus and ket minus. You have Y basis, wherein which I have plus I, then minus I. Okay, given a qubit, I can measure it in any of these bases. So 0, 1 is called the Z basis, plus minus is called X basis, I minus is called the Y basis. Okay, now, so what is the basis now? A basis is a pair of directions where we can measure the given qubit. Okay, so now imagine I have 0 state and then I have 1 state. I have 0 state and I have 1 state. What is 0? I am writing in the form of vector representation, or I am writing it in the form of a column matrix. So 1, 0, ket 1, I am writing it as 0, 1, right? I am writing ket 0 in the form of column matrix. Ket 1, I am writing in the form of column matrix. Again, yesterday also, I think Balkrishnan sir I think Balkrishnan sir said, Ganeshan sir also said in the morning, it is all about the representation. You can have vector representation, you can have matrix representation, you can have block sphere representation. When you read the literature, we get bombarded multiple people using multiple representations. Okay, so we need not worry, because we know all of these representation, we can understand very easily. So ket 0, 1, 0 and ket 1 is 0, 1. what do you mean by measuring this particular qubit in this particular Z basis? When I am measuring means I am asking whether the qubit is in the state 0 or whether the qubit is in the state 1. That's what is the measuring the qubit state. Similarly, what about X basis? X basis means we have seen X is, you have plus minus. I have also written here for your convenience, plus minus. What is the gate representation, which is the superposition? 1 by root 2 ket 0 and 1. 1 by root 2 ket 0 negative phase 1, right? So this we have discussed yesterday, today also. This is your X basis. How do you get it? By applying, Hadamard gate, you can get the superposition states. Now, what do you mean by measurement in X basis? Measuring in Z basis, you are asking the qubit, are you in 0 or 1? Measuring in X basis, you are asking, are you with plus or are you with minus? Because the basis in which you are measuring is X basis. So you are asking the question whether the qubit is with plus state or the qubit would be of minus state when you measure it. Okay. Now, what would be the measurement in Y basis? You are asking the question, plus I or minus I, right? So measurement in Y basis is the answer whether the qubit is aligned with plus I or minus I. So measurement means you are measuring in which basis? Okay. I think yesterday or today morning, Ganeshan Varsar was giving one beautiful example. What are your marks? What is your grade? Okay. Actually, you are doing measurement only, but the basis for measurement is there, it is the marks, and here it is the grades. In a similar fashion, you can think you are measuring the qubit in the X basis, you are measuring the qubit in Y basis, you are measuring in the qubit in the X basis or Y basis. Obviously, the question is different. When you are saying I am measuring in the qubit in the X basis, the question is different. The measurement in the Y basis, question is different. So now imagine I am having 0. I am having 0. So I am starting with qubit state 0. I am starting the qubit state 0. So what I am doing is measuring it in the Z basis. What is the question I am asking? If I am measuring the qubit in the Z basis, what is the question I am asking? Are you 0 or 1? So what I started? Get 0. What would be the answer? What would be the answer? So the answer is qubit is already in the state 0. Is it in the superposition state? It is simple qubit 0. So when you measure it, what you will get? 100% result, which is 0. Okay. 100% result 0. Now I have get 0. What is the basis I am measuring? X basis. What is the question I am asking? Are you in plus or minus? Are you in plus or minus? What is the question when I asked here? My qubit is in 0 only. When I am measuring, I am asking the question, are you in 0 or 1 when I am measuring it in the Z basis? Now I am measuring in the X basis. My basis is changed. My question is, are you with plus or minus? So now what happens? In X basis, what is 0? What is 0 in X basis? So when you apply 0 in X basis, what actually happen is 1 by root 2 plus minus. Now then 50% chance to get people, you should get a doubt. I will not answer because you have not asked the question. I am asking the question, how this has come. If I apply Hadamard, what I get? If I apply Hadamard, what I should get? When I apply Hadamard over 0, what I get is this. When I apply Hadamard 0, what I get is this. You are asking the question, I am in plus or minus. So for ket 0, 1 by root 2 plus state plus minus state. How this has come? Huh? Again, Hadamard, actually, madam, Hadamard, you get this. When you apply Hadamard over 0, what you get is this. What is this? When you apply Hadamard, what you get is this. When you apply Hadamard over 1, what you get is this. So the transformation, what you are getting is the Pauli X gate, right? So 50% chance to get plus, 50% chance to get minus. So when you measure 0 in X basis, what you are getting is 50% chance to get plus, 50% chance to get minus. Now I am measuring 0 in Y basis. I am measuring 0 in Y basis. What is the question? Are you aligned with plus I or minus I? Okay. What is the question I am asking? Are you aligned with plus I or with minus I? How do I represent it? 1 by root 2 plus I plus minus I. Right? What is the operator? Y. So now when you ask this question, measure it, what is the output? 50% chance for plus I, 50% chance for minus I. Now, no, it is about the basis. Your qubit is in some position. Now, in which basis? It is like this, sir. Again, see, the point is, you are getting very good doubt, but how to answer this? When we are, it is this. You see this bottle, when you see this like this, it is different. When you see like this is a different. When you see like this is a different. Your bottle is same. The basis in which you are seeing the bottle is changing. That's what is the changing in the bottle. Sorry, changing the basis. Measurement change. Okay. So the view that we see, that's what top you see. Z basis is looking from top down. So you are seeing top down. X basis is looking at the qubit from the side. You are seeing it like this. It is X side. Y basis is looking